In this chapter, I introduced you to the clean architecture and the guiding architectural and design principles that are supporting this architecture. We discussed where you should be using the clean architecture and what kinds of problems it solves. We also took a deep dive into the individual layers of the clean architecture and what you will typically define there. And lastly, we discussed the system that we are going to be building as part of this course, which is the apartment booking system. Now let's start writing some code, and we are going to begin with the domain layer. Welcome to the domain layer chapter of this course, where we are going to be implementing the clean architecture domain layer for the apartment booking system. Let's do a quick recap of what we're going to define in the domain layer. We're going to have our entities and value objects for representing our domain model. Then we're going to have domain events and services, interfaces for the various abstractions that we're going to need, like repositories and the unit of work. We're going to discuss the use of exceptions and whether they are appropriate or not. And of course, we're going to add some enums to better express our domain model. Now let's take a look at a high-level diagram representing the entities which are part of our domain. This is a high-level diagram of the apartment booking system representing the core entities that are part of the system. We have the user, which is the person using the system and making the bookings. Then we have an apartment, which can be booked by the users of our system. An apartment has an address, a name and a description, a list of amenities, and what is the price of this apartment. An apartment can be booked, which creates a booking entity. It encompasses all the relevant information for a booking, such as the start and end date, what is the price of the booking, and a few datetime objects representing the significant events for this booking. Lastly, we have the review entity. A user can leave a review for a completed booking, highlighting their experience during the period. And we're going to use the review, since it's connected to the apartment via the booking entity, to calculate the average review rating for this apartment, which the users of our system might find useful when deciding which apartment to book. Now that you've seen the high-level entities that belong to our system, let's see how we're going to translate this conceptual model into a rich domain model in the code. The system that we're going to create is called Bookify, and I'm going to start from a blank Visual Studio solution and show you how to implement the clean architecture. I'm going to start by defining a set of solution folders which are going to hold my projects. The SRC folder, which is short for source, is going to hold the actual source code for the Bookify system, and I'm also going to create a new solution folder which I will call test. This is where the test projects of our system are going to live. Now we can define the domain project, and I'm going to create a new class library. I'm going to call it Bookify domain, and it's going to be a .NET 7 project. I'm going to quickly do two more things. One is adding the word Bookify to the solution dictionary so that we don't get this spelling error. And the second thing is getting rid of this default class, which is added to every new .NET project. So I'm going to delete it, and we are going to start from a blank project. I'm going to start by introducing the core domain entities, which are the apartment, user, booking, and review. How should you structure the entities in your domain project? So I'm going to add a new folder, which I will call entities. And this is something that you will commonly see in clean architecture implementations, where you are grouping your classes by the type. In this case, all of your entities will live inside of the entities folder. I don't think this is a good approach, and I prefer grouping the entities in the domain layer based on the feature they belong to. So we are going to rename this folder into apartments. This is going to better represent what we have inside of this folder. So let's add our first class, which is going to represent the apartment entity. My personal preference is making all of my classes sealed if I don't intend to inherit them at any point. It might give you a small performance improvement in some situations, but for me, this is mainly a matter of conventions. Let's start by adding the properties that are going to be required to represent the apartment. And the first one that I'm going to introduce is going to be the ID of this apartment. Then I'm going to add respective properties for the apartment name. And we're also going to copy this and create one more string property for the apartment description. The apartment also has an address, so let's go ahead and add a few properties to represent that. I'm going to add a property, which is going to be a string representing the country where this apartment is. Then I'm going to use this to define a few more properties. So we're going to have a state, then we're going to have a zip code, we're also going to need a city, and I'm going to copy this one more time to define the street property. This is enough to represent the address of this apartment. Now let's see how we would model the price. So I'm going to add a decimal property for the price amount. We're also going to give it a getter and a setter. And I'm going to add a string property for the price currency. This would represent what is the price of this apartment for a one-night booking. And I'm going to copy it and define a few more properties for the cleaning fee amount and currency. So let me define the cleaning fee amount and cleaning fee currency. We're almost done with the apartment entity. Let's go ahead and define a datetime object, which is going to represent what is the last time when this apartment was booked. So I'm going to be using UTC times to represent my datetime objects. And in this case, the last booked on property could be null because this apartment may not yet have a booking. An apartment could have a set of amenities which represent the benefits this apartment offers. So I'm going to model that using an enum. So I'm going to create a new enum which I will call amenity. I'm going to add some of the possible amenities in our system. So we have things like Wi-Fi, air conditioning, parking, having a mountain view, a garden view, and so on. How are we going to represent this on the apartment entity? A simple way to achieve this is to define a list property which is going to contain a set of amenities for our apartment. And I'm going to assign it a new list by default. Let's review what we have so far. The apartment entity is what I would call an anemic domain model, meaning it only acts as a bag of data with a bunch of properties and it has no behavior. So we want to be using a rich domain model, and I'm going to show you how we can apply some domain-driven design principles to make this apartment entity look much better. I mentioned the word entity a few times already, but what does it actually mean? An entity is an object in your domain that satisfies two important qualities. It has an identity, so something that can tell you this is the specific object of this entity. In our case, this is going to be the apartment identifier. And the second thing that's important for an entity is that it is continuous. This means that the existence of this object is important throughout the lifetime of our application, and because it has an identity, it can evolve and change over time. Having said that, it would be useful to have an abstraction which is going to represent our domain entity. So I'm going to create a folder which I will call abstractions. And inside of it, I'm going to add a new class that is going to represent the entity. So let me create the entity class. This class should be abstract. You can't create an entity instance, you can only inherit from it. Inside of the entity, I'm going to define the identifier property, which is going to uniquely identify this entity inside of our domain. And I'm going to give it an init setter, which means that once we define this entity, its ID is set for life. Another important aspect to consider is the equality of entities. Two entities are equal if their IDs are the same. So if we have two apartment objects in our system, they would be equal if the IDs of those objects are the same. If this is something that is important for your system, you can go ahead and override the equals method and also implement the IEquatable interface. I'm not going to be doing that right now because I don't think it introduces any added value. Let's go ahead and define the constructor of our entity base class. So we're going to give it a protected constructor, which is going to accept the value of the ID and set the property. Now we're going to head back to our apartment class, and I'm going to make it implement our entity base class. This also means that we need to get rid of the ID property because we would be hiding the one on the base class, and I also need to define a constructor that accepts an identifier and passes it to the base constructor of the entity base class. With the entity class in place, we can now identify what are the entities which are part of our domain model, and we can slowly begin to build the rich domain model.